Constant of proportionality. This is going to be fun stuff. These got big words I like. You remember before I gave you the equation y equals kx. In that equation, k is the constant of proportionality. It's a number that doesn't change. That's why we say it's constant. And it's the value you multiply x by in order to get y. Now, when we were working with the tables before, what we did is we just divided the two numbers from one column to the other to see if we got the same number every time to determine if it was proportional. Same kind of idea here. The only difference is the order that you do that division in matters. You want your dependent variable, or your y, dependent, which is your y, to be on top, and your independent, which is your x, on the bottom. So we're going to do our y divided by our x, or our dependent divided by our independent. So the best way to kind of explain this dependent and independent is with some samples. So let's do a sample. All right, my first sample. You're working for a clothing store at the Commons. Yay, we like the Commons. The store gives incentives for you to sell the merchandise. For every 5 pair of jeans that you sell, the store gives you a coupon that can be used anywhere in the mall. And you're like, cool, man, that's awesome. So, what is the constant of proportionality? That's what we have to find out. Well, you have to look at the information that's given to you. Okay, I have 5 pair of jeans and then a coupon. One of these is dependent on the other one. Which one do you think? Hopefully you say, oh, the coupons that I receive depends on the sale of jeans. Oh, sale of jeans. Sale of jeans. Okay? However many coupons I get, well, that depends on how many jeans I sell. So that means that the coupon up here is my dependent variable. Again, coupon depends. That means that the jeans is my independent variable. So if I said x and y, independent, this is x, dependent, this is y. So if I wanted to find out the constant of proportionality, I would say, all right, well, 1 coupon for every 5 pair of jeans. Your calculator, 1 divided by 5, and you get 0.2 as your constant of proportionality. So that means that if I were to use that equation before, I would have y, which is the coupons, is going to be equal to k, which is our constant, times x, which is the jeans that I sell. So I have y is equal to 0.2x. To prove to you that this works, if I took y 0.2 times 5, in other words, I sell 5 pair of jeans, then this should be equal to 1. And you do in your calculator, and hey, it works. So let's say you're at the store and you're trying to figure out, let's see, this month, what did I sell? Oh, and I sold 30 pair of jeans. How many coupons am I going to get? Take 0.2 times 30, the number of jeans. And you say the number of coupons I would get is 6. And you're like, oh man, cool, I'm going shopping. But the most common use for this is with money. So we're going to do some money samples here. Now, a little clue that I have for you, and that's why I say remember. When you're dealing with money and you're asked to find a constant of proportionality, what they're really asking for is the unit price. So if you took the price divided by the items, you would get the constant. So the price divided by the items would give you your constant. And again, this is your y, this is your x, so if you had to graph it. So let's say you go over to your neighbor's house because he just did some landscaping, and you're like, oh man, look at all this rock you put down here. It's beautiful. And he said, yeah, I know, I really like it, and I got it cheap. And like, oh yeah, how much did it cost you? Well, I got 6 tons of it. It was only $75. And you're thinking, well, that's nice, but what's the cost per ton? Because if I wanted to do it in my yard, I don't need 6 tons of rock. But she's like, I have 6 tons and $75. So this is the information that he gave, 6 tons and it's $75. and you're trying to find out the constant. Now, what I said is the money goes on top and the items underneath. Those 75 divided by 6. And why is that? Because the cost is dependent on how much rock you buy. So that's why you would set it up like this. If you did this division then, you would find that the cost or the unit price is $12.50 per ton. Pretty cool, huh? But what if they're both money? Oh no. Here's one that's both money. Your employer gives you matching contributions to your 401k. Okay, some of you are probably saying, what in the world does that mean? It's common to go to an employer and they have a savings account for your retirement. They call them 401ks, 403bs. There's different names for them. And a lot of times, if you save money, the employer will give you money if you put money away, which is kind of a cool thing. So let's say here, this employer is saying for every $2 you save, they'll pay you 50 cents. And you're like, oh, well, that's nice. I mean, that's lovely. But here, you don't have money over an item. You have money over money. So you're like, wow, how do I set this up? Again, look, you have $2 that you save, and they pay you 50 cents. So which one's dependent? Which one's independent? I want you to think about that for a second. Pause the video, see if you can figure it out. Hopefully you realize that this one right here is independent. It's completely up to you whether or not you put money away. But how much they pay you will completely depend on how much you put away. So when you're setting this up, you would do 0.5 for 50 cents. That's your dependent divided by the $2, which is your independent. Again, what they pay you depends on what you save. When you do this division, you get 0.25 as your constant. So now put this... well, here, let me prove it to you first. I know some of you guys are really big on proof. I need to see everything. I need to be proved. Okay. Our y value is going to... I shouldn't put an equal sign there. That'll be confusing. Our y value is going to be equal to 0.25 times x. And remember, this is our y. This is our x. So in other words, up here it says, if I save $2, I'm going to get 50 cents. So what I'm going to do is take 0.25 times 2, the $2 I save, and it should be equal to 50 cents. In your calculator, do the math, and look at that. It works. Oh, my gosh. So let's say you're trying to figure things out. You're like, man, what would happen if I save $500 a month? Well, you would put it into this equation. It would be 0.25 times 500. And you would say, oh, my gosh, they would pay me $125 a month. That means I would have $625 saved. This is amazing. Yeah, and it is amazing. If you get an opportunity when you grow up and you're working for your employer to pay you to save money, by all means take it. Matching contributions is beautiful. Now, a common thing that I see with people is this. They say, all right, well, an employer knows that they can't match everything. So they set a limit, okay? So let's say the employer set a limit here of $150 a month that they'd be willing to pay on their contribution. You're like, well, okay, how much do I have to save to make sure that I get that $150 from them? I don't want to save any more, but I want that full 150. That's something that a lot of people try to figure out. Well, good thing you're in Mr. Jones's math class, because now you know how to do it. You'd say, all right, well, $150 a month. And what value is that? That is that y value in our equation. So we have in this, y is equal to kx. Our y is 150. Our k is our constant value, which is 0.25. And what we're trying to find out is this x. How much do I have to put away in order to get their maximum 150 bucks? Now, this is a one-step equation to solve. In case you forgot how to do this, as a quick reminder, 0.25x means 0.25 times x. In order to solve for x, you do the opposite. The opposite of multiplication is division. Whenever you do on one side of the equation, you have to do on both sides of the equation. These wipe out, and then you have x is going to be equal to 150 divided by 0.25. In other words, if you save $600, they'll give you the maximum of $150. Pretty cool, huh? I think so.